Hey everyone, I am to be. My salutation to the viewer watching this video. And now, here's my continuous alternative assessment of control systems. So, I come from EC department. Mm. It goes like the topic is open loop versus closed loop control systems, and of course, with some examples. And here it is. So, to begin with, inception. What is a control system? So basically, control system is is a system by which the output is controlled depending upon the input. So the input which you give obviously gets an output, but the output can be controlled. We'll be getting a feedback, and without the feedback also can control the output depending upon the input. This is how a system can be controlled. And to be precise, the definition of the control system is a system designed to manage, command, or regulate the behavior of other devices or systems through controlled inputs. So the input is controlled, and finally the output can also be controlled. So the purpose of this is to achieve desired output. Obviously, when the input is given depending upon our wish, and then the output is also getting depending upon our wish. So it basically, yeah, it holds importance. It holds the importance of uh, it is essential for efficiency and effectiveness in modern engineering, manufacturing and automation. The current world runs with AI, but initially there were only automations or human manufacturings. So the combination of both is AI, and this control system by using the feedback can be implemented in AI to to do the both operations like automation and the manufacturing. So we'll begin with open loop control system. Here is the simple one, the unidirection path. There will be no feedback. Whatever you give the input, you'll get the output. You'll be getting no feedback from the output. So it's like you just give the input, you'll be getting the output. It's an independent operation. The control action is completely independent of the output. The system follows the predetermined instructions without monitoring results. So you'll be getting no results. Like the output is given, but no matter what the output is, you'll just get the same thing. I mean, you'll get the output depending upon the input. That's it. There's no change. And the feedback, there is no feedback. Lacks any feedback mechanism to monitor, measure, or just based on the actual outcome achieved. So it's predetermined. The output is given, output is got just simply depending upon the input. You cannot change anything. If you want to change depending upon the output, you can change by just getting the output. You cannot measure that. You cannot predict that. It's just given, and you will take the output. That's it. So it's like operates based on predefined instructions, fixed timers, or programmed sequences, regardless of environmental changes. It would be like an example. So like putting upon a sensor where where you give the input, like you detect the motion. That's a sensor. So it just detects the motion, no matter is it a physical one or a mechanical one, whatever the motion is, it just detects that. But if we give certain feedback, like it has to detect only certain thing, then we can get the precise output. And depending upon the output, we can change the input also. So the next one is example. It's a washing machine timer, simple toaster, timed sprinkler system. These are the precise examples of open loop examples. of open loop control system. There is the first one is washing machine timer. So no matter how many clothes you put into that, it washes. Once the job is done, once the timer reaches certain time, it obviously stops and dries the clothes. And here the task ends. That is how it works. It's simple. The toaster, when you put the bread into that, after certain time, it just stops and it gives the thing. And then last one is time sprinkler system. So let's put a time sprinkler. It sprinkles the water at certain time. It's like if you put the timer as 3 hours, so for every 3 hours, it sprinkles the water. No matter if it rains also, if the weather is so cold and it actually rains, all those environmental changes when they'll never bother sprinkler. The sprinkler just sprinkles the water after every 3 hours. That's it. No matter what the weather out is. So this is how an open loop system works. And here are some advantages of open loop system. The first one is simplicity. The operation is so simple. You just give the input, you'll get the output. That's it. It's not too complex and it is completely simple. The cost effective. It's so simple, right? So it does not take much budget of us, and it's stable. Its stability does not affect. It does not. The stability of that does not get affected by any noise, oscillations. Nothing. Nothing is gonna change. Nothing is gonna affect that. The speed. It's obviously faster because there is no feedback. There is no data collected from the output. It just does the task given by the input, and you'll get a so simple. And the next is the main thing, the control loop system, the intelligent feedback loop. It can be named intelligent because it gives us the output feedback so that we can change the input depending upon the output. It's like set point. Desired output value is established and the output is measured. So we'll get the feedback. And the comparison. Error is calculated from the difference. So in the last example, the water sprinkler keeps sprinkling the water after every 3 hours. Even if it is raining outside, it does not change. It does not bother. It keeps sprinkling after every 3 hours. So this flaw can be corrected using this control loop system. So if you keep an weather sensor to that time sprinkler, you can just calculate the temperature outside and you can stop sprinkling the water and wasting the water. So here's the correction, the example of that. So uses feedback to compare actual output with the desired output. Then adjust input to minimize the difference between actual and desired states, also known as feedback control system. Here, the main difference is that we get the feedback from the output. Here is an example for that. The closed loop system examples. Thermostat control heating. So it's a device which measures the heat and then it maintains the temperature of the room. So measures the room temperature through sensors and adjusts the furnace to maintain set point temperature automatically. So obviously the furnace needs to be temperature of the furnace needs to be maintained and that temperature is maintained depending upon the temperature of the room. And obviously automotive cruise control. It's like automotives are so famous nowadays. These all are controlled using these all are um, well developed and came into force just by using this control loop system. So it can be believed using this because it controls the sorry it predicts the next step. It predicts the next move um, that comes in front of the vehicle. So it's like monitors vehicle speed through sensors and adjusts the throttle to maintain a set speed, compensating for hills and wind resistance. So it predicts the outside temperature, um, forecoming, steeps and downs, weathers, everything. It actually helps a lot. And the elevator level. It's like uses position sensor to ensure the elevator floor is perfectly aligned with desired floor before opening the doors. So it's a major thing. The lift does not open if it doesn't reach the floor. Once it reaches the floor, no matter you drag or you pull, it actually opens. Because the sensor there works and the output is collected and the given input is like to open the door. It works well in that area. So here are the advantages of closed loop system. Accuracy, obviously, depending the output is collected and the feedback is given to the input to, to manage the changes, and reliability automatically corrects from disturbances, variations, and unexpected changes in system behavior. Adaptability. So it gets changed depending upon the system parameters. And complexity in handling. It's complex to handle the thing. So because a lot of variations occur and those variations needs to be maintained, uh, it's a tough task to do. Here are the key differences between open loop and closed loop control systems. First one, open loop. In the open loop, feedback mechanism is absent. But when the closed loop, it is present. And accuracy. Accuracy in open loop is low. So the task completion is done, but the desired task is not done in the open loop system. But in the closed loop, the desired task is done depending upon the variations. And the complexity. There is no feedback. Open loop is simple. There is feedback, so more complex. Cost, same thing. It is lower. And the closed loop, it is higher. Disturbance handling. No feedback, nothing. Just the job is done depending upon the input. So it is poor in disturbance handling. And the last one is stability. The open loop is more stable, and closed loop may also oscillate due to the variations that are brought in the output. So which one is best? Open loop or closed loop? So depending upon the human use, we can just uh, put our priority to the open loop or the closed loop. So when we use in a simple, household appliances, predictable manufacturing process, and cost-sensitive applications, we can use open loop. And in the closed loop is used for the bigger things like environmental changes, like in the traffic signals, um, temperature predictors, rainfall predictors. So then they all needs to be maintained, and they all needs to be maintained the forecast. It is good to maintain closed loop critical safety systems. We choose wisely depending upon our priority and our use, whether it is a closed system or an open loop system. This is how we use these applications. And here is the end of the presentation. And thanks a lot. Thanks for giving this opportunity.